Greetings to all and welcome to the channel Simtech05. This is the third video of Abaqus basic training. In previous two videos, we seen some basic command of part modeling and some basic options for the meshing. Today also we will look at some important feature of the meshing. They may help you to precisely mesh your component and that prevent divergence of the solution many times, especially if you have intersection of the elements in case of assembly. So in previous case we simply gone for global seeding, define the seeding size. We not seen the curvature control and these other options. We only use the global size, apply and OK. Then go for mesh. If I go for mesh using the first options, what will happen? All component those available in this part will be meshed together. Likewise, see all three component meshed, but I don't want to mesh all the three component at a time. I want to define different element size, density for the particular component, edge, surface, and want to mesh individually. So instead of meshing using the first options, we will go to mesh the region wise. So I'm going to delete first meshing. Okay, in previous two videos we consider only one hook component and for that we gone for meshing. But instead of one component, here we have three components, three hook components. That's why name is hook 3. So we can mesh this hook with different meshing schemes and can compare by visualization on the same screen. So global meshing is 2, that's okay, that's fine. And I want to mesh the first component. So go to the mesh the region instead of complete part. See, the all splitted portion of the part of the components are region. So I want to mesh these all regions of the first part. So you can select by shift and mouse button first, likewise, and click on mesh. If you are okay with this meshing, then that's good. But in many cases, we may have stress concentration region, especially if this component is just for assumption. I'm going to hold this component from this end. I'm going to apply some load here. So this may be our stress concentration region, and here in this region we need the high density meshing. So what we can do, we can utilize the local seeding option. See, my global seeding is still 2. Okay. Now I'm using here the local seeding. Once you go for the local seeding, it will ask where you want to define the local seeding. Sometime you may not able to select this edges properly, because this selection options is selected as all. So you may try to select the edge, but software detect the surface. So change it into edges or faces or cells, whatever your requirement. So my requirement is edges because I want to define the local seeding on the particular edges. Likewise. But this selection process may little bit lengthy. What else you can do? You can go with some standard view. Make sure you are in the parallel view instead of perspective. I'm deselecting all edges. See, select these edges, those likewise, select these edges, those I want to select. And then deselect those I don't want to select. So you have to be a little bit habitual of it, selection and deselection, and you can select. So in this way also you can select. Click on done, then define the local seeding. Here we have local seeding by element size or by element number. Again we have here curvature options, same as in the global seeding. Bias, variation in element density linearly. So we'll talk sometime on this point also. Here I'm going to define the element by size. What size I want? Because this is my stress concentration region that I'm assuming, I'm defining the approximate element size is 0.5. Earlier the global element size was 2. Click on apply, likewise, and you can go for the OK. The most important point, you have to create the set, because if you want to modify anything, you not need to select those edges again and again. I am saying element size 0.5. This is the name of the edges. Whatever name you feel good, you can keep. Click on OK. Then go for again mesh region and select these regions. Now click on done. Now you can see very beautifully software able to define more number of element on the particular concentration region. Of course, you can reduce the element size along the length also. What you can do, you can go again with the local shading, select these edges, click on done, and I'm defining again the element size around 0.5 and click on apply. Make sure the delete message, because you want to modify something. Click on delete and have a look. And if you want to bias them on the particular direction, just click on this bias options. The bias will be along this direction, and here we have bias parameter. So the element size maybe minimum is 0.4 and maximum is 2. You can change. Click on apply. Now you can see here we have less element size, then continue element size is growing. OK, and again go to the mesh this region twice. So element density will be increased here. Can we improve this element quality further? Yes, we can improve. How? By splitting it little more. So let's try. I'm going to delete the meshing. Delete the meshing for these regions. OK, fine. See, if I want to define the elements on this particular edge, the same number of elements if I'll define on this edge, then it will try to make a rectangular type of shape here. But problem is that this edge is very shortened as compared to this one. So what I can do, I can split this particular face from here. So instead of splitting only the face, I suggest to split the whole solid component, solid region. So again go to the same options, partition, select the partitions that you want to split, 3-point options, and split. Similarly, I can use these and can go with the 3-point, first point, second point, and this may be my third point. Oh, not this. You have to delete this particular feature that you created. This is my partition 2. Right click and delete it. Resplit. Select these two features. 3-point. This is my first point. This is my second point. And this is my third point. Now it's okay. Similarly, for better meshing, I am going to split this region also from this point. Select these regions. Not point and normal, but I can utilize the point and normal. I can utilize. Select the point, select the normal. One more split I want to create. Point and normal, select point, normal. That's fine. Now again go to the local seeding. Make sure you not use the previously defined local seeding. If you previously define any local seeding and you modify in the geometry, then I suggest to delete the existing one. Likewise, select this all edges, delete, go to redefine, go to standard view. These edges I want to modify. That's fine. No bias, element by size, and size I want to define 0.5. Edge seed 1 or whatever name. Click on apply, then OK. Further, I want to define seeding on these two regions because I'm assuming this region is my stress concentration region. So select this edges precisely, and again by size, and here also I want to define size around 0.5. Now OK. Here I want to define around element size 1, then it's OK. Now go to the mesh. Mesh the regions, not the complete component. So let's see what meshing you will get. Draw. As compared to the previous condition, we will get a beautiful meshing that having element density, perfect element density on the stress concentration region. Away from the stress concentration region, element size is coarser. So in this way, you can utilize the seeding options. If you remember, during the local seeding, we created some set in the definition. And if you want to modify the element density or number of elements on the particular selected edges or surfaces, you can utilize those sets. Those sets are available in the particular part and in the sets. Here we have set 1, set 2, set 3 and some another set. You can visualize them. So to modify the element density, again you have to go with the seeding options. Instead of selecting edges from the viewport, go to the set and surfaces options and the list of the sets available to you. Make sure you check on this highlight options. Select the edge seed 1, edge seed 2. This will be highlighted in the viewport. So I want to modify the edge seed 1. Click on continue. May I want to increase the element density from 0.5 to 0.8. No need to create set again because it is already created. Click on OK. Again, if you want to modify density on the different set, like here edge seed 2, click on continue, and 0.8, click on OK. May you want to modify edge seed 3 set also. Click on continue, and here instead of 1, let's say 1.2. Click on OK, dismiss, and done. So without selecting these edges, you are able to modify the element density because earlier we created the sets. Make sure where we created the sets, see, like I selected edge and here create the set. Once you click on the create set and define the name, the set will be created that you can utilize later for modification. Go to the mesh regions, select the region precisely. No need to select this all region. Even if you select the particular region, software will able to define meshing, or you can go with the individual meshing likewise. So I'm selecting the all regions again, go for mesh, and meshing is done. In the same video, I also want to explain the minimum size and curvature options. Those are available in the local seeding as well as in the global seeding. So let me create some circular hole in this component, third component. Go to the extrude cut options, select the particular face and edge that you want to define as a right vertical. Let's create a hole of dimension around 3.6. So 3 is more than sufficient. Make sure it is in center. And through all, click on it. So this hole is created. Go to the matching options and now go with these options. Global seeding, number of hole around the circle. Here the minimum 8 element it will create around the circle with the curvature control of 0.1. This value is actually a ratio of height to length, so it will vary from 0 to 1, in between 0 to 1. If you define lesser the ratio, then it will increase number of element along the hole. Let's say instead of 0.1, 0.05, so 16 element at least it will create around the hole. Let's see. Similarly, this also is cylindrical feature. If it is required to increase the element density, here now already elements are more than 16, so it is not going to increase. But let's say instead of 0.5, 0.1 and click on apply. Now you can see element density along the whole circular feature will be increased. But if elements are already more than the approximate number here, software will not improve the density. Like if you select here 0.4 and click on apply, it is increasing, but initially it was like 0.1, 0.1, and here the 8 minimum number of element along the circular feature. So here already more than 8 element. So even if you try to reduce 0.05 and click on apply, no density change here because element on this feature already more than 60. Okay, then you can mesh this feature likewise. So element density is at least 16 around the hole. Similarly, you can increase from 0.05 to 2. Now element density will be 39. Click on apply. Okay, but the meshing will be very. See, this is the meshing. Similarly, you can control the minimum size also. So the minimum element size should not be less than 0.1 per 0.1 time of global element size. So here the global element size is 2, so element size should not be less than 0.2. Or you can define a absolute value. This is the minimum size control and this is the curvature control. That's all. Just cancel it. Mesh these regions also. And you can see the difference. Without local seeding, with local seeding, and with the curvature control. So that's all for this video tutorial. In next video, we will look little complex component and different splitting method. After that, we will go with the combined meshing. Like in one component, some features you cannot mesh by hexa element. So on that region, you want to define the tetra element, but apart from that region, you want to define hexa elements. So how we can go with the mix meshing in the same component? If you have any query or question, you can put in comment section. And if you want to join our Facebook and Telegram community for the Abaqus simulation and other finite element analysis discussion, you can join. The link is available in the description. Thank you again.